Hi everyone, today we will discuss modulus function. When we say modulus function, so we are only interested in the magnitude part of the function. So suppose if you say f of x is equal to mod of x. So if we consider this f of x equal to mod of x, then whether x is positive or x negative, but we want the magnitude part of this, the magnitude, only the mod part of this. So this modulus function, this is termed as mod function, and the meaning of this is only the magnitude of that function. So we are not interested in whether x is positive or negative. Even if it is positive or it is negative, that mod of x, it should be positive. So that is the meaning of this modulus function. So if you consider this f of x is equal to mod of x, then this is equal to x. If we consider this f of x equal to mod of x, then this is equal to x when x is greater than equal to 0. Means when x is already positive, when this x, in this interval x is positive. So when x is already positive, to remove this mod sign, this is the symbol that we use for the modulus function. Mod of x means we will represent it like this. So within two vertical bar, we put this any variable and we say that mod of that quantity. So here it is mod of this x. So if we consider in this interval when x is positive, so when x already positive, so we don't have to do anything, we simply write f of x equal to x because this x itself is positive. But if this x is negative, let us say when x is less than 0, so if this x is less than 0, it means x is negative, but we are not interested in the negative value of the function, we are interested only in the positive part of it or the positive value of the function. It means we have to do some operation to make it positive. To make a negative quantity positive, what should we do? We should multiply with the minus sign. So that's what we have done here. So f of x equal to minus x when x is less than 0. So x is negative. So don't confuse that this becomes a negative quantity because x itself is negative and minus of that of that negative quantity, that becomes positive. So here f of x, it is positive. Here also it is positive. Whether x is positive or x is negative, we observe that this f of x equal to mod of x, it is positive in both the interval. So that is the meaning of the modulus of a function, mod of a function or magnitude of a function. Now if we take some example, let us say if we consider few example, suppose f of x is equal to mod of x minus 2. So f of x equal to mod of x minus 2. Now you want to remove mod from here. So first, because all mathematical operation, whether it is addition, subtraction, multiplication or division, that you can do on a mod function when you will be able to remove that mod, that function or that quantity from the mod sign. We can't do any operation keeping the quantity within the mod sign. So first we have to remove this mod sign. Now just to remove the mod sign, because it completely depends on whether x minus 2 is positive or x minus 2 is negative, and x minus 2 is positive in which interval, x minus 2 is negative in which interval. Depending on that only we will be able to remove this mod sign. So greater than 0 or less than 0, that gives us the concept of positivity or negativity. So x minus 2 is 0. First equate the function, first equate the expression to 0 and find the value of x. It means at that particular value of x, the function or that expression becomes 0. It means beyond that point, either it will be positive or it will be negative, and that boundary point, that boundary line we have to decide or we have to choose. So x minus 2 is 0 at x equal to 2. So this is 0 at x equal to 2. It means if x is greater than equal to 2, this will be positive. If x is less than 2, this will be negative because it is 0 at x is equal to 2. Here f of x equal to mod of x. This is 0 at x equal to 0, and that's why we have considered this interval x greater than equal to 0 or x less than 0. Here x minus 2 is positive or negative whether x is greater than equal to 2 or x is less than 2. It means the interval you have to break at what? You have to break, or you have to decide at x equal to 2. So here we will take two interval, that is x minus 2 when x is greater than equal to 2. This will be minus of x minus 2 when x is less than 2, because in this interval x greater than equal to 2, x minus 2 is positive, so mod of x minus 2, it will remain same as x minus 2. In this interval x less than 2, x minus 2 is negative, so mod of x minus 2, it has to be positive. To make that positive, again we have to multiply with this minus sign, so minus of x minus 2. So this is the value of the function in this interval, this is your value in this interval. It means now you can write this will be 2 minus x minus minus plus 2, so it becomes 2 minus x. It means now you have two values of the function f of x. F of x equal to x minus 2 when x is greater than equal to 2, it is equal to 2 minus x when x less than 2. Now whatever operation you want to do, depending on your requirement, you will be doing at f of x equal to x minus 2 in this interval, at 2 minus x, f of x equal to 2 minus x in this interval. So you have now two separate problems. Whatever you want to do, whatever is your requirement, you have to consider this as well as this. I hope this is clear. Similarly, let us take some more example. So if you consider, suppose f of x is equal to mod of 2x minus 3. So if we consider f of x equal to 2x minus 3, and we have to remove the mod sign from here. So again we have to check at which point it is 0. So 2x minus 3 is 0 at what? 3 by 2. When x equal to 3 by 2, and that is not, okay, I am just calculating. You can directly or orally, depending on nature of the question, you can calculate, or you can have, we want that this should be 0, and corresponding to that we want to calculate the value of x. So from here you will get x equal to 3 by 2. So x equal to 3 by 2, it means the sign of this function or sign of this expression will change whether x is greater than 3 by 2 or whether x is less than 3 by 2. So it means my interval will be decided at this point. So using that, let us define the interval, and accordingly let us define the value of the function in those intervals. So can you write this is equal to 2x minus 3 when x is greater than equal to 3, and this is equal to minus of 2x minus 3 when x is less than 3 by 2. So now again we have two different values of the function f of x. One is f of x equal to 2x minus 3 when x is greater than equal to 3 by 2, and another is minus of 2x minus 3 when x is less than 3 by 2. So now we have two functions, or you can say two problems in two different intervals. Depending on your requirement, you can simplify, you can proceed further, and you can get your desired result. This will be your minus of 2x plus 3. So either you can leave it in this form, or you can simplify and you can write 3 minus 2x. So that way we calculate and we remove the mod sign, we get different values of the function, and accordingly we use it wherever it is required. I hope this is clear. Now let us see how the graph of this function f of x equal to mod of x behaves. So if you see this graph, in this interval x greater than equal to 0, f of x equal to x, take any value of x in this positive interval, whether you have x equal to 0, whether it is 0.5, whether it is 1, whether it is 2, whether it is 2.5, 3, 4 and so on. This is clear. Value of f of x is always positive. F of x means what? Y. So value of y is positive. It means x is positive, y is positive. Okay, so if x is equal to 1, f y is equal to how much? 1. If x is equal to 2, y is equal to 2, x equal to 3, y is equal to 3. So you take f of x, x is equal to 0, y is equal to 0, x is equal to suppose 0.1, y will be 0.1, x is equal to suppose 1, y will be 1, x equal to 2, y is equal to 2 and so on. Here you will get all this. Clear? Now when we consider this, so if you join this dotted line, because it is a linear function, f of x is equal to y it is equal to x. It is a linear function. Linear function means the highest power is 1, x to the power 1. So it is a linear function, and the graph of the linear function always it is a straight line. It's always a straight line. So you have y is equal to this x. So when we join all these dotted points, we will get a straight line. So you will get this straight line. Now at what angle? This straight line will be inclined at what angle? So y is equal to x. So tan theta, if you say this angle is theta and this is your y and this is x, so tan theta is equal to what? Y upon x. So for every value of x, y is same. When we take x is equal to 1, we are getting y is equal to 1. When we take x equal to 2, we are getting y is equal to 2. It means value of y and x it is same. So this divided by this will be what? 1. So this is always 1. So tan theta is 1 means theta is equal to how much? 45 degrees. So this line is inclined at angle of 45 degree. It's clear? Similarly, now let us come to the negative part of this. So if you consider when x is less than 0, we have f of x equal to minus x. As I have just told you, and again I will repeat, don't get confused that this is negative quantity. This is a positive quantity because x is negative, and negative of negative, that becomes positive. So negative of this x negative, so that becomes positive. So it is also a positive quantity. It means when we take negative value of x, means this side, y still is what? Positive. So when you take x is equal to suppose minus 1, y will be plus 1. When you take x equal to minus 2, y is equal to plus 2. When we take x equal to minus 4, y is equal to plus 4, and so on. So it means x is negative, but still y is positive, and that is the definition of your f of x equal to mod of x, that it is always positive whatever be the value of that x. So this side also it is positive. Again, if you consider this y is equal to f of x, and that is equal to minus of x. Taking this x negative, we are getting y. So again tan theta will be what? Tan theta again that will be equal to minus of 1, because y is positive and x is negative. So both are always same. When x is equal to minus 1, y is equal to 1. X equal to minus 2, y is equal to 2. So both are same in magnitude, but one is with the positive sign, another is with the negative sign. So that gives you tan theta is equal to minus 1. When tan theta is equal to minus 1, so again theta, the principal value of that, it will be equal to 45 degree, but in which direction? In the clockwise. So with respect to negative x-axis, it will be 45 degree. With respect to negative x-axis, this is 45. So again you are getting this 45. Here also we got this as 45, but this was in the anti-clockwise direction. This side it is anti-clockwise direction. Angles are measured in the anti-clockwise direction with respect to positive x-axis. That is the standard convention. So either you say this is 45 degree here because plus 1 and plus 1. That makes tan theta is equal to plus 1. Or when we are getting tan theta is equal to minus 1 here, tan theta is equal to minus 1. So theta still it will be 45 degree, but with respect to clockwise direction, with respect to negative x-axis in the clockwise direction. So then only you will get this. Otherwise, with respect to this line, this angle becomes what? 180 degree minus 45 degree. So that becomes 180 degree minus 45 degrees. So it will be equal to how much? 135 degrees. So this becomes your 135 degree. So either you say this line is at an angle of 135 degree with respect to positive x-axis in the anti-clockwise direction. This is the standard convention that we always maintain as far as the measurement of angles are concerned. So 135 degree in the anti-clockwise direction with respect to positive x-axis. Either you say this statement, in that tan theta or tan 135 is minus 1, or you say it is 45 degree with respect to negative x-axis. With respect to negative x-axis, 45 with respect to negative x-axis, you will get tan theta is equal to minus 1. because already you have decided, or already you are taking this negative of x-axis. So in that case, here we are taking positive x-axis. So in that case, you have to consider this entire angle, because you are measuring with respect to the positive x-axis, considering that angles are always measured in the anti-clockwise direction, and that is taken as positive. So this is 135 degrees. So from here it is 135, from here it is 45 degrees. So either way you can you can measure the angle, but you have to be clear in your mind what is this 135, why 135 here and why 45 here. This 135 is with respect to positive x-axis, this 45 degree is with respect to negative x-axis. So these things you have to be clear in your mind. Otherwise, when we have the general solution as far as the trigonometrical functions are concerned, you will always be under confusion whether I should take obtuse angle, whether I should take acute angle, whether I should measure it from the positive x-axis, whether I should measure it from the negative x-axis, clockwise or anti-clockwise. So just to avoid any confusion, you should always be clear in your mind what the convention you are using and in which direction you are measuring the angles. I hope this is clear. So it means both these straight lines, either you say this is straight line or this is straight line, both are at 45 degree, either with respect to positive x-axis or with respect to negative x-axis. So it means if we finally consider, so we have this straight line and we have this straight line. Okay, so and both are equally inclined, this side as well as this side. So it is a symmetrical function because both are inclined at same angle with respect to x-axis, and you can extend this straight line up to your desired requirement. So this is the graph of the function f of x is equal to mod of x. F of x is equal to mod of x, because y, whether it is in the first quadrant or in the second quadrant, it is positive. X is positive in this quadrant, x is negative in this, but in both the quadrant y is positive. Here y is positive, here also y is positive. So this way we can represent the graph of the function f of x equal to mod of x. So this is f of x equal to mod of x. Similarly, you can draw the graph of the function mod of x minus 2. Just breaking the interval, as I have told you, take this x greater than equal to 2, x less than 2, again x minus 2, it is a linear function, so that will be a straight line, but that will not originate from 2 because it is not 0 at x equal to 0. So it will not originate from 0, it is 0 at x equal to 2. So from there you have to start the graph. So you try yourself, and in the coming videos we will be discussing how to plot the graph of the function f of x is equal to mod of f of x. In general, you can say how to plot the graph of the function mod of x. So when we get into the depth of this, when we start more and more topics, so we will also discuss the graph of any type of function, you can say, whether it is x minus 2, 2x minus 3, mod of x plus mod of x minus 2 plus mod of 2x minus 3, and so on. Let us say you have this function f of x is equal to mod of x plus mod of x minus 2 plus mod of 2x minus 3, and so on. Or you can have, we can have various ways. We can have mod of trigonometrical functions like mod of sin x plus mod of cos x, mod of tan 2x, mod of sin 3x. How to plot the graph of all those functions we will discuss in the coming classes. So I hope this part it is clear. Now let us see some of the properties of the mod function. See here, if you have mod of, this is an inequality based on the modulus of the function, mod of x less than equal to a. So mod of x, if it is less than equal to a, and if you remove mod from here, this directly you can say that minus of a less than equal to x, x less than equal to a. Mod of x less than equal to a. Again you will consider what? Either this is the interval. Okay, the inequality mod of x less than equal to a. Now we have to solve this inequality. How to solve this inequality? So mod of x less than equal to a. So remove mod sign from here. Now how to remove this mod sign? Again we will consider the what? The interval. So again if x is greater than equal to 0, this mod of x will be equal to what? X means x less than equal to a, and this will be equal to minus of x when x less than equal to 0, sorry, x less than 0. X greater than equal to 0, mod of x it is same as x, so you will get x less than equal to a. In this interval minus x less than 0, you will get what? In the another interval when x is less than 0, you will get mod of x is equal to minus of x. So this is the equation that we are getting. So let me consider this. So x less than equal to a, and here you will get what? X greater than equal to minus of a. X greater than equal to minus a. Just see it again. Mod of x less than equal to a. So can you say x less than equal to a when x is greater than equal to 0? Let me be clear here. Mod of x is equal to x in this interval. Inequality is less than equal to a. Again mod of x, that will be minus of x less than equal to a when x is negative. And x less than a. Now x less than equal to a, that inequality we get from here, and this statement says what? X is greater than equal to minus of a, because if you change the sign, the inequality is changed. So here we have this minus, so remove this minus from here, and that we can remove multiplying both the side by the minus sign. So minus minus it becomes x, so this will be minus a here, this will become x, but the inequality is changed as soon as you change the sign of the function. So x will be greater than equal to minus a, so x greater than equal to minus a. Now combine these two. So in a combined form, either you can write it in the same form as far as your inequality is concerned, or you can combine them together. This statement says x is greater than equal to minus a, means minus a is less than equal to x, and this statement says x is less than equal to a. So one says greater than minus a, another says less than a. So what is the value of x? X lies between minus a2 plus a, so minus a2 plus a. Okay, so it means either you have to do all this calculation to remove this mod sign to develop the inequality, or if you can keep this in your mind, whenever there is the less than sign here, it means remove this mod and you will get this interval for x. X lies between minus a to a. So mod of x less than equal to a means x lies between minus a2 plus a, any positive and negative of this. So x lies between the positive of this a as well as the negative of, so minus a2 plus a. Hope this is clear. Now just consider the another property. Mod of x greater than equal to a. So now here the inequality, here it was less than, here it is greater than equal to a. So if mod of x is greater than equal to a, again you can use the same logic. So this is equal to how much? X greater than equal to a, mod of x equal to x when x is positive. So it is greater than 0. Gives us that x will not lie between the two constants a as well as here x is less than equal to minus a and x is greater than equal to a. So this says it is greater than equal to a and this says it is less than equal to minus a. This is your greater than equal to a and this is minus a. So this side. So a to infinity and from minus a to minus infinity. It means x does not lie between minus a to plus a. So we are getting this. So whenever you see mod of x greater than equal to a, just you don't have to consider so many things, because once you have understood, clearly you can use that wherever it is necessary. So x will not lie between minus a or plus a. So x less than equal to minus a or x is greater than equal to a. Now see the other properties. Mod of x plus y, this is your function, mod of x plus y, that is equal to mod of x plus mod of y, provided x is positive and y is positive. If x positive, y positive both, then directly we can separate the mod, and we have mod of x plus y is equal to mod of x plus mod of y. Or if x is negative y, if x as well as y both are negative, then also it is valid. If x and y both are positive, then also it is valid. Is this clear? So mod of x plus y is equal to mod of x plus mod of y if x is greater than equal to 0, y greater than 0, or x less than 0 and y less than, both simultaneously negative or both simultaneously positive, then we have this relation. Now here again, if you consider this mod of x minus y, that is again mod of x minus mod of y, provided mod of x is positive, mod of x is greater than equal to y. Is this clear? If mod of x is greater than equal to mod of y, means x is always greater than y, whether it is in the negative side or positive side, but x is greater than y. That is the meaning of this condition. Mod of x, whether x is positive, negative, mod of y, whether y is positive or negative, it means they are always mod of x is greater than mod of y. So under that condition, we will have this equality sign, mod of x minus y is equal to mod of x minus mod of y. Here also you have this. All these condition means they should have the same sign. X is negative, y is negative. Is this clear? And mod of x is always greater than mod of y. Whether x is positive or negative, y is positive or negative, but x is always greater than y. So if these conditions are satisfied, then simply you can write mod of x minus y is equal to mod of x minus mod of y. Now, for any other condition other than this, if this is not satisfied, then what happens? Mod of x plus minus y is less than equal to mod of x plus mod of y. If you have individually the addition of two mods here, mod of x plus mod of y, so mod of x plus mod of y is always greater than equal to mod of x plus minus y. So here that is the thing here, mod of x plus minus y, it is equal to the sum of the two mods individually, less than or equal to mod of x plus mod of y. So that way we can consider. Just see it again. We have this total mod of x plus y or x minus y, that is less than equal to your mod of x plus mod of y, means here we have separated the magnitude of x and y. So addition of the magnitude, individual magnitudes of x and y, that is greater than the magnitude of x plus y or x minus y. That is the meaning of this property. So we have to keep, and all these relations are frequently used, some of the algebraic concepts, some of the concept in calculus, and you have to make use of it wherever it is required. Now consider the next property, mod of x plus minus y, that will be greater than mod of x minus mod. Here it is less than, when it is the addition sign here, that you can see. Here it is greater than when you have this minus sign. It means the subtraction of the two individual mods, mod of x minus mod of y, that becomes less than mod of x plus y or mod of x minus, whether it is mod of x plus y or whether it is mod of x minus y, that will always be greater than if you have subtraction of two individual mods, that is mod of x minus mod of y. So that way again we can calculate this. Here if you see this, here mod of x, this is one part, and then again it is mod of this entire quantity. So mod of x minus mod of y, it may be positive, it may be negative. If x is less than y, in that case it will be negative, but you have to consider the positive part of that, that this is the entire mod. This gives you the mod of this entire quantity. So mod of this entire quantity, it is less than this mod of this x plus y or x minus y. So you have to see this. Here we have mod of x minus mod of y. It is not only mod of x minus mod of y, mod of x minus this mod of y. So it means we have to consider only the positive part of this. Mod of x minus mod of y, it may be positive, it may be negative, but you have to take only the positive part because of the presence of this mod sign. So these are the properties of the mod sign or the inequalities based on this mod. If you can keep this in mind, that will be better and you can use wherever it is required. I hope I was able to clear these concepts. So we have seen the basic concept of this mod function, we have seen the graph of this modulus function, and we have seen some of the properties of the mod function. Thank you.